At the end of the topic, you will be able to define refraction, explain the laws of refraction, determine refractive index of a medium. What happens when you insert half the length of a stick inside water? Yes, the stick appears to be bent due to refraction of light. Light travels in a straight line only when it moves in a single medium. Its velocity is maximum and constant in vacuum. When light travels from one medium to another, it bends at the surface of separation. This happens because the velocity, that is, its speed as well as direction, changes at the surface of separation of the two media. This phenomenon is refraction of light. Let us look at the reasons for refraction. Velocity of light depends on the density of medium. The velocity of light in water is less than that of air. The reason is water is denser than air. Hence, light travels slow in dense medium. When light ray traveling in a certain medium enters another medium, they bend at the surface of separation due to change in its velocity. That is, the velocity reduces when the light enters from a rarer medium to a denser medium. Now we will discuss the angle of refraction. We have learned when light passes from rarer medium to denser medium, it bends. The angle of refraction measured with reference to the normal line. Remember, normal line is the imaginary line drawn perpendicular to the surface of separation of two media. The angle between the refracted light ray to the normal line is the angle of refraction. On the other hand, if the light travels from denser medium to rarer medium, it bends away from the normal line. The velocity of light increases when it travels from denser medium to rarer medium. The refraction of light is described by two laws of refraction. The first law of refraction is the relation between the incident angle and the refracted angle of light to the normal line drawn on the surface of separation. It states that the ratio of sine of angle of incidence in the first medium and the sine angle of refraction in the second medium is constant. This constant is the refractive index mu of the second medium with respect to the first medium. The law can be expressed as sin I by sin r is equal to 1 mu 2. This law is also called as Snell's law. Using this relation, we can calculate the refractive indices of different substances. The second law of refraction states that the incident ray, refracted ray, and the normal line drawn at the surface of separation of media lies on the same plane. Let us discuss an experiment to determine the refractive index of a glass slab. Take a glass slab. Place it on a drawing paper. Draw the outline of the slab with pencil. Remove the glass slab and label A, B, C, D. Draw a normal line N to the face AB. Mark the point O. Now, draw an incident ray at an angle, say 30 degrees to the normal. Fix two pins P and Q on the incident ray. Place the slab and observe images of P and Q at the side CD. Now fix two more pins R and S along the refracted line, so all pins must align in a straight line. Remove the glass slab. Now join RS with O'. Also connect O' and O with a line. Now measure the refracted angle R. Repeat the experiment for different incident angles, say 35 degrees, 40 degrees, 45 degrees, 50 degrees, and so on. Find the refracted angle and tabulate them. Then find the ratio of sine of incident and refracted angles. You observe that the value sin I by sin r is constant. The average value of sin I by sin r is the refractive index of the glass slab. In this topic, you have learned velocity of light decreases in denser medium. The bending of light rays when it travels from one medium to the other is refraction of light. The ratio of sine of angle of incidence and the sine of angle of refraction is constant.